Thank you to watching Shoaib Views channel. Today you will be watch Steam Turbine Overhauling Part 2. In this part I will be explain through pictures how many points in your mind to overhaul the turbine. Steam Turbine Overhauling. Steam turbine overhauling is a process that restores the performance and efficiency of a steam turbine. It's important because steam turbines are used to generate electricity and power industries. What's involved in steam turbine overhauling? Cleaning, removing mineral deposits, rust scale, and other buildup. Balancing, ensuring the turbine is properly balanced. Lubrication, applying lubrication to bearings and other moving parts. Inspection, checking the turbine for issues like misalignment, bearing failures, and vibration. Testing, testing electrical components, combustion components, and control systems. Alignment, ensuring the turbine's components are properly aligned. Why is steam turbine overhauling important? Overhauling keeps steam turbines running efficiently and reliably. Overhauling helps extend the life of steam turbines. How often should steam turbines be overhauled? Overhauls are typically performed at prescribed intervals based on operating hours or cycles. When you are purchasing equipment, a vendor gives you schedule for its maintenance. Now I tell you the turbine maintenance schedule. Class of periodical overhaul inspection. Class of periodical overhaul inspection are classed as follows. 1. Class A inspection, complete inspection. In this overhaul inspection, the steam turbine is completely disassembled, and the turbine rotor and nozzle diaphragms are removed from the turbine casing for inspection. Turbine control components such as the main stop valve MSV, control valve CV, etc. are also disassembled for inspection. Class B inspection, semi-complete inspection. In this overhaul inspection, the upper casing is disassembled, and the turbine rotor is holding in the lower casing for inspection. Turbine control components such as the main stop valve, control valve, etc. are disassembled for inspection. 3. Class C inspection, simple inspection. In this overhaul inspection, the steam turbine is not disassembled, but the bearing inspection is carried out if required. Turbine control components such as MSV and CV, etc. are disassembled for the inspection. When overhauling a steam turbine, overhead cranes are crucial pieces of equipment used to safely lift and maneuver heavy turbine components like the rotor, casing, and blades during disassembly, inspection, repair, and reassembly processes, allowing technicians to access and work on various parts of the turbine that would otherwise be difficult to reach due to their size and weight. Key points about using overhead cranes in steam turbine overhauling. Lifting capacity. Overhead cranes need to have sufficient lifting capacity to handle the large and heavy components of a steam turbine. Precision movement. Precise control of the crane is vital to accurately position components during the overhaul process. Accessibility. The crane design should provide access to all necessary areas of the turbine for dismantling and reassembly. Safety features. Safety features like load limiters and emergency stop mechanisms are crucial to prevent accidents during lifting operations. Typical applications of overhead cranes in steam turbine overhauling. Rotor removal and installation. Lifting the entire turbine rotor out of the casing for inspection, repair, and balancing. Blade replacement. Accessing and replacing individual turbine blades that may be damaged or worn. Casing section removal. Lifting and positioning casing sections to access internal components for maintenance. Bearing replacement. Accessing and replacing bearings within the turbine housing. Mobile cranes are used in steam turbine overhauling to safely lift and maneuver large, heavy components of the turbine. This process often requires disassembling significant parts of the turbine, including the rotor and casing, which can be extremely heavy and difficult to handle manually. Mobile cranes provide the necessary lifting capacity and mobility to transport these components to the overhaul area, facilitating both efficient maintenance and repair operations. Dismantling a steam turbine involves a detailed process of disassembly, inspection, and reassembly. The steps typically include loosening and removing bolts, cleaning components, checking for damage, applying anti-seizure agents, and carefully reassembling and tightening everything. It's crucial to inspect all parts thoroughly during this process to ensure safe and efficient operation after reassembly. This chart shows you coupling bolts and holes clearance. In this figure you can see how to remove the casing bolts and lifting the upper half. This figure shows the lifting the upper casing of turbine and removal of diaphragm. In this figure you can see the turbine rotor removal. Turbine leak off steam. A steam turbine leak of steam refers to a situation where steam is escaping from a steam turbine, usually due to faulty seals or worn components, causing a loss of efficiency and potential safety concerns as the escaping steam can be very hot and under high pressure. Identifying and fixing these leaks is crucial for maintaining optimal turbine operation. Key points about steam turbine leaks. Causes: worn seals, gland seals, labyrinth seals, damaged or cracked components, improper alignment, erosion or corrosion, high vibration. Impacts: reduced turbine efficiency, energy loss, increased maintenance costs, potential safety hazards, detection methods, visual inspection, infrared imaging, acoustic leak detection, pressure monitoring, solutions, replacing worn seals, repairing damaged components, adjusting alignment, implementing preventative maintenance practices. Steam turbine testing and measurement involves evaluating the performance of a steam turbine to ensure it meets expectations. This includes measuring the turbine's output, calculating its efficiency, and comparing it to the expected performance. Steam turbine testing and measurement of rotor runout refers to the process of inspecting a steam turbine's rotor by measuring how much it deviates from a perfectly straight axis while rotating, essentially checking for any unevenness or wobble in the rotor which could lead to vibration and potential damage if excessive. This measurement is typically done using a dial, indicator, or other precision measuring tools while the rotor is slowly rotated in a controlled environment, allowing technicians to identify and address any issues with the rotor alignment and balance. A steam turbine generator coupling test runout refers to a measurement taken during a test procedure to assess the radial deviation or runout of the coupling connecting a steam turbine to a generator shaft, essentially checking how much the coupling's alignment deviates from a perfect circle when rotating, which is crucial for smooth power transmission and minimizing vibration and stress on the components. This was Steam Turbine Overhauling Part 2. I think you can like it. If you like this video, please subscribe my channel Shoaib Views, like, follow and share this video. Please keep watching Shoaib Views. Next episode to be will be released soon.